Okay, we'll go ahead and start recording on this Chapter 5 lecture, which is on the topic of debugging. And what's really interesting about this lecture is I know you've more or less seen these tools at least in 2 other classes, if not 3. So when we're talking about breakpoints, when we're talking about the watch window and the locals window, that's all this chapter is. This is the standard tools built into Visual Studio. I also know this. So even though I'm sitting here going, look, you guys have seen this before, I also know that students get intimidated quickly when it comes to using these tools. So I could sit here and like downplay it and say, oh, this is easy. You guys got this. You've seen this before. But you might have seen the tools, but are you comfortable using them? And probably, even though you guys are more experienced, I was just giving you guys all the credit in the world compared to like newbie developers, I don't know everyone's individual comfort level using these tools. Right? So I am going to teach these tools as if you've never seen them before in attempt to make you feel more comfortable. Because as you've seen errors in this system, they are difficult to troubleshoot. So having an understanding of these tools is foundational to finding problems. Now, what's the first debugging tool that anybody typically does? Like, before you even look at a debugging tool, all of us, the first time, like, my code doesn't work, the natural thing is to just open up the code and what you could call hunt and peck, right? You just look through your code and you're just what I would just call manually hunting and pecking for your bug. And that is where you start. When it comes to troubleshooting, everyone naturally just starts clicking around. Obviously you're going to have an error message, and so you're going to start by reading that error message, and then you're going to hunt and peck. If you're anything like me, you get that error message and you don't give the error message its I don't know if due diligence is the right word, but you don't. Hey, Hussein, if you're going to have a conversation, could you step outside, please? Thank you. You don't just stop and critically look at the error message. In this system, in this format, I have now taught both, and before this class, I've taught this class before. Okay? I've taught this class before, and I've taught the JavaScript section now. Okay? And I think Sam said it, and I think probably multiple people have said it. My experience has been troubleshooting in the JavaScript class has been a little bit easier to debug and find the problems. Because there's a lot of assumptions being made here. There's a lot of following the pattern, following the convention. And so my hope is by going through these tools, we all find it a little bit easier to debug on this side. All right? Point is, just on the surface, it's a hard system to troubleshoot. It is challenging. But you really got to start by looking at that error message and critically looking at it. And that doesn't just mean like, let me copy and paste it into Google. All right, let me copy and paste my error message into Google. That means, what is this error message trying to tell me? Because at the end of the day, this is software trying to tell me what my problem is. And software is only so good at doing that, right? Software is actually, in a lot of cases, not that great at telling me what my problem is, which you could consider to be like a best attempt, right? Is a software problem giving it its best attempt at telling me what my problem is. You forget a semicolon. Well, if you go to build this, it's pretty good at finding missing semicolons, right? It's going to tell you semicolons. That's an easy one, right? But you get anything more complicated than this, oftentimes the error message can be a bit cryptic. And I really think that taking your time to try and decode what that error message is saying is in your best interest. Because again, what I'm guilty of is just like almost overlooking the error message, not critically looking at the error message and say, really, what is this trying to tell me? Okay. After that, we do the hunt and peck. Okay. Try and understand the error message. Okay. We're going to do a little hunt and peck. And then after that, we need to start looking at these tools. If the hunt and peck method doesn't solve it within a matter of 5 or 10 minutes, we need to look at these tools. And I will tell you that in my troubleshooting, like my day job is to troubleshoot code. My day job is when students write bugs, I have to find them. So my workflow as someone who debugs code for a living is I hunt and peck for even just a couple of minutes. I don't spend a lot of time hunt and pecking. Okay? Just looking through your code and looking for the actual error. If I spend a couple minutes and I don't see it pretty quickly, I'm going to put in a breakpoint. Okay, and obviously that's one of the first tools that this chapter goes over. Okay, so when it gets into here, let's just kind of dive in, and we have seen this before. I think it's in like chapter 1 or chapter 2, we learned that hey, we have off of this drop down. Well, by the way, first off, these two play buttons are different play buttons. Does everyone realize that? This play button says start without debugging. Okay, so that will launch this website a little bit faster. Okay, so Control F5 or off of the debug, start without debugging. That's what you want to do most of the time if you're just trying to launch it quickly and you don't think you have any bugs. Okay, so these two play buttons are different. This one is to start the application with debugging. And what that means is that all these extra debugging tools and all these extra debugging features are going to be available to you. So in this mode, if your website breaks, aka hits an exception, and it can't correct that exception, there's no try catch for the exception, it's just going to give you a big red screen on the website full of exception errors, right? So we've all seen that, where we start without debugging, you hit an exception, and then it gives you a really unfriendly error message to the user. If you've ever used Inside Rankin, by the way, Inside Rankin is notorious for just giving you that error message. Okay? We're going to learn, it's not in this chapter, but instead of giving an end user an ugly exception message, we're going to learn how to make a friendlier something went wrong page, right? And for this class, I know we're all like using chess.com because this class is like me. They're all many of them are addicted to chess. Not all, but we all play chess a little bit. And chess.com is overloaded right now. Chess is like super popular, so their servers are overloaded, so their website's constantly crashing. Oh, that's horrible. And instead of getting a red error message that says a bunch of gibberish to the end user doesn't see that. The end user just sees, we have a problem. And actually their problem page, you guys familiar with this, is a YouTube video of Gotham Chess explaining what's going on. So the error message on chess.com is a YouTube video. And it says, here's what's happening. The popularity of chess is blowing up, so the servers are overloaded, and it's basically a scaling problem. They need to put more resources, more money into their server capacity to handle the influx of users. But they've grown so fast, they haven't put that money in. Okay. Point is, if your application crashes right now, you get the exception. Remember what an exception is in C#. An exception is an object, okay? And if you don't handle that exception, it crashes your program, okay? It throws a 500 style error, 500 meaning server logic is crashing your program. So exceptions crash your program. You see the red error message, okay? And if you start your programs with this, start without debugging, and your programs crash, that's what will happen. If you start your programs with this, and that same exception occurs, instead of seeing the exception message in the website like the end user would see, the exception message will be inside of Visual Studio. It's literally not a big difference. It's the same exception message, but frankly, those exception messages are not meant for end users. Those exceptions are meant for programmers. They're meant for our eyes. Okay, so in the real world, what happens? In the real world, the website crashes, that exception message gets logged into a database. So every time an end user crashes the website, it's just generating a log. And then a developer can go into that log and see how many users are getting this website crashing message, right? And so that's real world. Website crashes, you give the user a friendly error message, okay? Not like you see on Inside Rankin, that's an unfriendly message. Okay, website crashes, overloaded, whatever the problem is. Log the exception to the system log, to the server log, and then a team of developers can go into this log and say, man, look at this. We've had 1,000 website crashes in the last day. And you can see all the messages as to why it's happening. Okay. So now with that being said, under this message, again, this is starting with debugging. Well, one of the problems that you might have, and this goes all the way back to the HTML days, one of the problems that you might have is that, well, users have different browsers. And different browsers will read the same code and interpret that code differently, right? So in a perfect world, we would write one set of code, and that code would look the exact same in Firefox and on Edge and on Internet Explorer and on Chrome and on Safari. And in a perfect world, our one set of code, which we want to write standardized code, we write that standardized code, it's interpreted the same across all the browsers. But that's just not the world we live in, right? Different browsers render code differently, and on top of that, different versions of the same browser render code differently, right? So if you have a bug, something's not acting right, one of the things that you want to figure out, is this a problem just with this browser, or is it a problem that's cross-browser, right? And the way that you can do that built into Visual Studio, thankfully, they just make it easy. You can boot this up in Firefox. If you have Firefox installed, keep in mind Firefox will update, like if you take a shower, Firefox will update. So I haven't booted up Firefox in a while. So now that I'm saying boot in Firefox, let me click on start. And it'll launch in Firefox. And it probably will take a minute because I haven't launched Firefox in a while. And Firefox says, hey, you have a website from localhost. Of course, I accept the risk and I continue. Okay. All all that big intro just to say, if you're having a problem, hunt and peck for it, test it across different browsers, right? Because different browsers will render your code differently, and they will have different problems. Mr. Gegelman here comes from Scott Air Force Base. Anytime you're working with the government, they're notorious, correct me if I'm wrong, for working with older technology.
Most times, yes.
Yep. And when you're working with older technology, you're working with older browsers. Older browsers have more problems.
Yes.
Yeah.
And the way they update things nowadays, especially with the programming languages, the old stuff gets outdated quick and it won't work on the new browser. So if you happen to open a new browser, a lot of it won't work just because it's not set up to run.
Yep. Yep. So especially if you go work on base, like this code that we're writing here, for whatever reason, their computers are locked down and they're on Internet Explorer 6, right? That's 20 years old, an internet browser from 20 years ago. Whatever the case may be, you're going to have a hard time getting this new C# code and this new .NET code and the latest HTML tags to work.
I have a question about why are they so procedural in that sense? Like, doesn't that pose a huge security risk on its own? Like, aren't they like kind of fighting their own, like building a situation that they're fighting, trying to combat actively? You know?
A lot of it, they know it's already stable, and so when they integrate something new, then they got to figure out, what's it going to break? What are the chances of getting hacked? Hacking is like a huge thing out there. I was telling Evan earlier, or Mr. G earlier, that we ran a program called Fortify, and it scanned all of our code, and they put rules in for it to look for. Like if you declared a variable but didn't have a value with it, it flagged it. You had to go in and take it out. If things weren't initialized right, you had to go initialize them to where they couldn't be hacked. It was all about getting hacked and making sure it was as secure as possible.
But to your point, yes, it is almost like you're fighting yourself because on one hand, you're not updating your browsers, which is a huge security risk. I think they're probably better about that today than they used to be, would be my guess. But he answered it spot on. I would agree 100% in that if it's not broke, don't fix it. And that mentality gets you working with some old technology. I mean, I've talked to enough employers, and they'll say you'll be surprised how many Windows Server 2003 machines are out there, or Windows XP machines are out there, are these old dot matrix printers that'll still print, just because they don't break.
Well, and it would take a while to convert all the code over to something else.
It takes a while. It takes money. It takes time. It takes resources. That whole ordeal with Southwest. Josh got caught up in the Southwest ordeal. Why? Old IT systems. Mm-hmm. Like at the root of that problem in December was you just had this old antiquated system that it didn't break, so why fix it?
I told somebody earlier today that a lot of it's not writing new code, it's maintaining legacy code that somebody else wrote years and years ago, and then you just make sure it doesn't break, and if they need a tweak to it, you go in and tweak it and make sure it works, and then you move on. Okay, so now you guys hopefully understand that there is a difference between start without debugging and start with debugging. If you're literally trying to fix a bug, you're going to be using these troubleshooting tools like a breakpoint. You come over here, you're going to click in this margin, set the little circle in this little margin over here on an executable line of code, typically something with a semicolon at the end. It's called setting a breakpoint. Okay, this breakpoint will allow you to step through your code line by line and look for a problem. Okay, of course, in order to hit that breakpoint, in order to stop the code from executing, you must start it with debugging, which is this green arrow right here, or start debugging, just F5. Okay, so that's kind of the first step into debugging. A newer feature for me, and I was unfamiliar with this, and you guys saw that, is this concept of the hot reload. You guys have now been messing with this for a couple of weeks. Do you like it? Do you not like it? What's your opinion?
I haven't messed with it at all, actually.
It's definitely worse than how it was in last semester.
Yeah.
It would update in real time, but I mean it's nice.
Yeah.
It's something similar.
So my experience has been this. Sam, go ahead. I'm sorry. Go, please. I didn't mean to cut you off.
about to say that yes, it is worse than what it was last semester, but the fact that we have like a real-time updater every time we save, it's convenient. It's nice. I like it.
Yeah. Here's my observation, and it's basically this. So if I were to launch this, okay, and I'm just going to launch without debugging. Okay, so you launch it, and okay, I'm in Firefox, and I'm gonna click on hot reload, and I'm just gonna hit hot reload. Okay, so now it would be nice if it gave me an indicator that I'm hot reloading. It doesn't quite do that. What I've noticed is that certain changes that aren't core changes, like if I just change the HTML, right? So I'm going to go on the front end here, and this is on the home page, and it says Sports Pro Technical Support, and then I've got this kind of thing here. So I'm just going to go into here. I'll go into Solution Explorer. I'll go into my let's see, I'm going to go into my shared folder here, and here's my layout, HTML, and I'm just going to change, look down here in the footer, like let's just change something in the footer. So here's my 2023 Sports Pro down here in the footer, and I'm just going to put my initials like right there, okay? Put my initials in the HTML. I go back, okay, it's pretty easy once you hot reload to see something simple like HTML. If I were to change something a little bit more significant like the C#, it's going to give me like a little warning. So let me just do, I don't know. So this is home controller. If I were to say var tech equals new technician and save this, nothing's changing here, but there's another error message that I got annoyed by. That when you change, maybe if I kind of let me do this, since it's not giving me that error message. Let me change the actual model. So if I were to go into the technician and change phone to phone number, click save. Yeah, I want the rebuild. It's not being nice with me right now. Normally you'll get a little like, do you want to rebuild this application? And I was getting annoyed with it, but it turns out you just got to say yes. You just have to say yes and just ignore that error, right? So if you were like me and you were getting basically annoyed because every time you would change like a little line of C#, so if you just like I said earlier, take your time, read the error message, see what it's telling you. What was it telling me? It said every time you change a C#, do you just want to recompile and rerun the program? You just say yes, and it'll handle it for you. Oh, do you know why it's not doing it? Because I forgot to hot reload on file save. So now if I do a save, meh, it's not showing up. I think because I already confirmed that yes, I do want that setting to reload. It's worth tinkering with. I'm not going to tell you got to use hot reload or not. Oh, I did have hot reload on file save. So every time you change it, let me try and give you a decent takeaway here. The decent takeaway with this hot reload, it can do some things pretty well. Other things that I would consider to be more heavier operations, you're going to have to restart the full application. So a lot of times I just find myself out of caution, just shutting it down and rebooting it.
It's pretty unreliable.
Yeah, that's been my experience. But it's nice to have something there, and it can handle simple changes like changes to the HTML, changes to the CSS. It'll do that pretty well. And again, to reboot it, you'll notice it does when you boot up this application. It just kind of get this command line going too. I close it completely from here. So I close the command prompt, and then I relaunch it completely. All right, so that's hot reload. That is a newer feature. That was not there last time I taught this, so this is a newer feature in Visual Studio. Oh, it even says it right here. Types of changes you can apply with a hot reload. Changes to most C# code and controllers, models, and Razor views. Changes to CSS. Here's, you just check this box, always rebuild and apply changes. And that's just going to go into your settings, and then you're not going to get this error message anymore, which is why I wasn't getting this error message, because I already clicked that box. Make sense? Okay. Another thing to do, as we've seen these troubleshooting tools before, is understand that, let me Control Z, undo my changes. Save. In the old days, when I was learning to code, you always had to compile before running your code. And so you'd write a little bit of, call it C++. And you had to do file compile and then file run. So compiling is this step that over the last couple of years and over the last decade has really just become lost. Visual Studio is always compiling your code for you. What does it mean to compile? It means it's looking for syntax errors. You forgot a semicolon. You forgot a semicolon, it gives you the little, it gives you the little red squiggly, you forgot a semicolon. There is no option anymore to compile, but there is an option to build. And so I will tell you that off of this build menu, if you want to make sure that your code is clean of syntax errors, oftentimes what you want to do is you want to come into here is you want to build solution. And you want to see this message, build succeeded. So if you're not exactly sure if Visual Studio is keeping up and compiling your code exactly on demand, you can do a manual build. Now sometimes build isn't even the most reliable, so sometimes you want to come in here and do a clean solution and do a rebuild. All of these things are basically, and I get you guys real quick, all of these things are more or less doing the same thing at deeper levels. Like a build is basically a compile, making sure you're free of syntax errors. But I've seen it before where just doing a build solution doesn't find a problem, and it's not until you do a rebuild solution that it really goes through and checks every file necessary for your software to run, and all of a sudden it finds some sort of error. Okay? So I'm not, like these three buttons, I'm not afraid to click them and use them frequently. Right? So if something seems to be acting a little wonky, I'll come in here and clean my solution, rebuild it, and build it, and make sure I've got no error messages. Okay? Ryan, you had a question.
So whenever you do just like the build solution, it'll say a 0 failed, 0 succeeded, whatever.
Yep.
And there's ones that say skipped and up to date. What do those two mean? So how is it?
I'm only concerned with succeeded or failed. Clearly you don't want anything skipped. You don't want it to skip anything. So if it is saying skipped, maybe that is a case for like maybe doing a rebuild and a clean, just to make sure it's hitting all the files. So if anything's saying skipped, I think what that is if you ever do a build and it has errors and it says, do you want to run from the last successful? You remember that error message? Always say no. Because if you say yes, it will run from like 3 versions of code ago that you have. That's probably where skipped is coming into play. Okay? Probably what you did somewhere along the way is you hit yes, go ahead and run it from like the last time it was working. But in reality, you just want it to build and compile your current code as it sits on your screen. Right? So yeah, good question. Vinny, you had a question?
Yeah, just curious. Is building the solution, like also known as compiling, is that when Is that when Visual Studio is converting it to binary?
So that is what's happening behind the scenes. So it's getting it into executable code. So there's two parts, and I'm getting a feel because you've talked about Java in the past, and we've never studied Java. So it's called Java is both compiled and interpreted. Okay, so what it means to be compiled and interpreted, C# is the same way. Compiled means your source code is free of errors. Interpreted means it's ready to be run. And it basically, what that means is it's going to take your source code and get it into what's called bytecode. Okay, bytecode can then be ran by a virtual machine. The virtual machine gets it into binary. So it's not exactly what you're saying, but it's basically getting there. It's a process that your source code is going through to run. So it goes from source code into what's called bytecode. Bytecode can be read by this thing called the virtual machine. The virtual machine can run your code, and that's how Java works. C# runs just like Java, and so all of that process is hidden from us when we click the play button. It's doing all this conversion for us so that ultimately it is getting into binary ones and zeros that can be understood by our processors. Right? Where'd we leave off? We left off saying, hey, another troubleshooting tool is to open this thing up in the browser and see actually what is being sent down to the browser. Because keep in mind, the server side languages like C# are going to send something to the front end through a view, and we want to make sure that what the client is receiving is this is the HTML that we want our client to receive, right? So another tool at our disposal is to use these front end inspector tools that we've used many times to say, okay, well, what is this? This is technicians. Why does this say technicians? It's an H1. What is the CSS that's being applied? It's over here, right? So this is just another troubleshooting tool. If we're trying to get some, a background color to take place, or a gradient, or a heading, and it's not working, these are troubleshooting tools. We've seen that, and these developer tools are now in Firefox, and they're in Chrome, and then are in Edge. They exist in every platform for the most part, pretty similar.
If you do web development, you'll be using that F12 a lot to check JavaScript and all that stuff.
Yeah, like pretty much every day, right? It's just a normal.
When you run it, yeah. It's a lot of times, even when you run it, you'll have F12 up while you're running it, just to watch and make sure everything's working right.
Yeah, and correct me if I'm wrong, but you guys are very familiar with these developer tools.
Yes.
You've used them now for semesters. Yeah. Cool. So there you go. F12. There's your hotkey. And again, kind of what you're seeing is the end result of what that view is sent down to you. This is that exception page that I got done saying, like, at the end of the day, we're going to learn to hide this from the end user. Like, at the end of the day, users should not see that. Now, I'm going to tell you, again, Inside Rankin is far from perfect, but just let me give you an example of this happening on Inside Rankin. So if I go ahead and log in, and let me zoom out just a little bit, and I click on this class, and I go to let me just open this up, and then I click this. A lot of times the back button doesn't work, so if I were to go, my demonstrations fail me. Sometimes I'm good at getting these things to break. Sometimes, of course, when you need it. I'm trying to think of, because I can't show you any grades. So a lot of times I'd go into the grade book. Let me go into coursework. Let me just click on a test that they haven't taken yet. 15 written test. Go to test builder. And let me go in a couple questions. Now let me click back. My demos are failing, guys. Have you guys all seen these nasty error messages on Inside Ranking?
Yes. Yeah.
So it doesn't matter that my demos are breaking right now. If you know what I'm talking about. Josh, have you seen them? If there was a sound.
Oh, yeah, and good luck getting to Inside Ranking if it's past like midnight, because it's just like slow down the servers.
Yeah, they scale it down a lot, so it takes forever to
I didn't know this.
Yeah, literally in like 12:01, like you can't do anything else like that anymore.
Get out of here.
Yeah.
Interesting.
Yeah.
What I said once already, I'm just going to repeat myself. These error messages probably tell us more than we give them credit for. It's just, do we take the time to try and understand it? I think they do a decent job at pointing us in the error. It's just, do we understand the language that they're giving us, that they're saying it in? And so here, SQL exception cannot insert null into a column inside of this table. And it says column does not allow nulls. Insert fails. Well, that's a database exception. Clearly the database has a schema that does not allow nulls for that particular column, right? And you can go into the SQL Server Object Explorer, right? And we can kind of come into our database. You go, huh, I thought inside of my Sports Pro database that the customers allowed nulls. So what you can do in here is you can right click on a table and view designer. And so I just want to show you guys this, whether you're familiar with this or not. On your tables, you can come into any one of these tables and see what are the data types and do they allow nulls. Well, there's actually only 2 columns that allow nulls. Yeah, give me just 3 minutes. Give me 3 minutes. Okay. And so Oladeji pointed out it is a good time for lunch. So we normally go on lunch right now. So I'm going to send you guys on break. Point is, this can cause those kind of nasty error messages to pop up, right? If you try and leave out some data that's required by your database. Okay, let's take a break. I'll pause. Okay, and so as I resume, one thing that was said off camera was I was kind of showing you how you could, in theory, go into your database, view designer, and make changes to your database design here. And naturally the question is, well, should you? And it was like, well, good point. No, we should not. Especially if we are doing a what's called code first model. And so this entity framework stuff that we're learning, it comes with 2 approaches: database first or code first. Code first says you make your models, and then based on these models, you build the database. We're doing code first entity framework. But there's the other approach, which is database first entity framework. Database first entity framework says you come over here to the database, create your database using SQL statements, create table, create database, kind of like what we did in the C# class. You create your database first. And so since we're using this code first, where we're making these models, what you should do is to determine whether a field is required is update the model. And by updating the model, then you add a migration, and then you update the database that way. So if you're going to change your database design, the right way to do it is through the model. So that we cover those bases there. And, we kind of left off on this page. This is the page. If you stop and look, there's actually some links down here that might be able to help you do some deeper troubleshooting as well. Like if you want to see the call stack by default, someone remind me, what's the call stack? Remember that term? Not ringing a bell? Any bells? No bells? It's okay. Haven't heard it in a while. All the call stack means is that ultimately some line of code tripped this error message. And the call stack is from the start of your application to that line of code, what are all the methods that were called in between? Right? So what the call stack is literally just the stack of methods that were called to say, okay, well, method 1 called method 2 called method 3 called method 4, and then method 4 was where this exception occurred. So the call stack is just that stack of methods that were called in order to ultimately cause this exception to occur. Why is that important? Well, if you don't understand why line 3000 is even executing, you have to understand the call stack to understand why line 3000 is executing. If you don't understand how you got there in the first place, you're not going to be able to understand, what's going on. So that's what the call stack is. Query and cookies. Well, what are the query parameters, right, that are a part of the URL? Because obviously part of the URL, you can get your IDs from the URL, or you can get these different input parameters. And so what are the different query variables? What are stored in cookies? What are stored in your HTTP headers? So there's a headers link, as well as some routing information as far as, what's going on with the routing in this application. So point is, there's some links down here that you can navigate up and down, and it will help you to understand, or potentially help you to understand, what's going on. So again, the name and description of the exception. Remember, the exception is the object that's crashing your program if it's not handled. If exceptions are handled, they don't tend to crash your programs, right? Remember, you handle them with try-catch blocks. Stack trace, we talked about that, and then all those links that you can click on. Now, this is if you start without debugging. This is what you see. But if you started with debugging, it's kind of the same thing, except for it's crashing and showing you this error inside of Visual Studio. It's more or less the same thing. It's just going to show you it in one place instead of another. So this is starting it with debugging. And with debugging, you get this exception helper tool that's going to allow you to view details and exception settings. And the one thing that is different, and I've never tried this, so maybe you guys will have luck with it, this little button link right here, start live share session. So supposedly there's a technician who understands MVC code, and you can share your screen. I've never done it. If you want to check it out.
Like Visual Studio technician?
Yeah, like Microsoft technician.
It's a real person.
Now, odds are they're going to want to charge you for this, right? Odds are this is not a free service. Like Microsoft does, they want to charge you for help.
I didn't know that's what that. I assumed that was like you could kind of collaborate with another coworker and you guys were both working on the same code at the same time. That's what I assumed that was.
Yeah, no, this is supposed to be a live help from a developer. And developers are so in demand, probably you're going to get a 404 developer not found kind of thing. I cannot promise this is any sort of quality. However, if you're stuck and want to check it out, it might be worth checking out.
Well, being that this is a Microsoft product, I'm imagining soon that's just going to be Copilot. You know what I mean? You click it.
Maybe
AI.
an AI that might be. Okay, so let's actually take a look at a breakpoint, because where this goes from here on out is really just talking about breakpoints and all the different ways to work with breakpoints. So let's just pull this back up. Let me close everything. Close all. Close all tabs. And I'll just go back to Server Explorer over here. Actually, I'll just minimize this. And Solution Explorer is over here. Okay. And I'm going to put a breakpoint inside of one of my controllers, home controller. And I'm just going to put a breakpoint in here. And so the home controller should fire up the home page. I'm a little scratching my head why it says 0 references. Let's go ahead and start with debugging. And okay, so this is what it looks like to hit a breakpoint, right? There's a lot to look at here, which I think is often why people tend to like get overwhelmed. I would start looking. There's a couple of places that are really commonly used. First off, these tools right here. Again, these are the tools you've seen every semester. These tools are Step Into, F11. And F11 is going to take you line by line through your code. Now, honestly, the controller sends it to the view sends it out the front door, so that's the last line of C#. That's the last back-end line of code, so there wasn't much to see. And so it did what I told it to do. It basically sent the view out the front door down to the end user. Let's hit stop again. Let's just hit that one more time. But how to hit a breakpoint? Okay, that's how to hit a breakpoint. Step over is this concept of like, hey, there's a method call. Let's just say that this method call on line 10, and you don't want to debug that method. Like, you know, that's a trusted method. You can step over that method call. So you don't have to go down into the method call, right? So that's stepping over, whereas a step into will step into that method call, right? So that's kind of the basic idea or difference between step into versus step over. You have any?
Is step over skipping it or just like
It is
still running it?
It's still running it, but you're not going to analyze it.
Gotcha.
You're not going to debug it. Okay, so it'll still run it, but you then just go to your next line of code outside of that method call. Well, step out is this idea of like, let's say you do step into a method call and you're like, wait a minute, I don't need to be in here. You can step back out of the method call. So that's what this button is right here, step out. So if you step into a method call and you're like, I don't need to be here, I should have stepped over it, but now I'm down in the weeds, I need to get back out. That's what step out is. And that's all that there are to those controls. Most of the time you're stepping into, most of the time you're just hitting F11 to go step by step through your code. It's worth noting, as something I see all the time is like the beginners will like just put breakpoints like sprinkles. They're just going to sprinkle them everywhere. I don't tend to do that myself personally. I tend to like try and isolate where I think the problem might be, and I just tend to hit one breakpoint. However, there is a point where it's like, okay, I might want to troubleshoot two different methods, and I'll put one breakpoint in one method, and I'll let it hit, and then I'll troubleshoot it, and then you can hit continue. And continue will step you out of this break mode. It'll keep running your software until it hits the next breakpoint. So you don't have to analyze every line of code, right? So if you do have multiple breakpoints, you can hit it, and then if you hit continue, okay, it should just keep running the program. So let me just run that over again. Okay, I hit my breakpoint. I just hit continue. Okay, now it's just going to keep running. Maybe I have maybe I put a breakpoint on the incidents page. So let me go back into my Solution Explorer. Let me go into my incidents controller, and I go to list my incidents. So here's my list, my incidents. I want to put a breakpoint in there. Okay, so let me stop and hit this debug. Okay, page is loading. I hit this breakpoint. I step through it a little bit. I make sure there's no problems. I'm gonna go ahead and click continue. There's no problems there. I hit my incidents. Okay, I hit this other breakpoint. So continue allows you to like go in and out of breakpoints. That's really all continue is. And then which point I can step into. Now this is actually kind of useful. I just stepped into on model creating. I don't need to be in here. So let me step into. You kind of see what it's doing right now is it's creating a bunch of products. It shouldn't need to do that. I already have my model created the first time. So let me just hit step out. Okay. So now if I step into, I'm going to click step over. There we go. We stepped over the creation of that. Here's my incidents, and there's my 1, 2, 3, 4. Okay. Point is I want to get to this window where I can look at some different things. So I just finished line 16, right? Line 16 had me digging into creating all these incident objects and to put all these incident objects in my list. I now have a list called incidents. The count is 4. I've got these different windows. I've got a call stack window. I could see the different breakpoints that I have inserted. A very friendly window that I like is this immediate window. Excuse me, over here. Immediate's right here. Autos, locals, and watch. Locals is really good because locals means locals to this list method. I can expand and basically see that what variables are in scope. I can see my incidents right here. I can see each individual incident. So here's sub-0 of my list. And here's the customer property, customer ID. I can inspect my data this way. Right? So this locals window, when you're in break mode, is very useful. Right? Because locals, what does that mean? That's in scope locally in that method. So what are the variables that are in scope? Most of the time, you can get the data that you're looking for, like right here inside of locals. If for whatever reason, the variables you're looking to inspect aren't there, of course, it's nice. You can actually hover, and I do this all the time. You see me do this. You can hover these variables and see the values as it's running in Visual Studio. So that's a really nice feature. You don't actually have to go into these different windows. Locals being what's in scope locally. Autos is a little bit more broad context than local scope. This is has a little bit more slightly global scope, I would say. And you can really get lost in here. Like notice under autos, I could see view data and view bag. I could see what's going on with view data and view bag as you start poking around through here. You can see view data count is 0, so really there's nothing there, right? But it kind of allows you to inspect different pieces of data throughout the application. A watch window, this is very manual. Like locals is useful because it's what's in scope. Autos is useful because it's what's in a little bit more global scope. But if for whatever reason you can't find, like if I got a string variable, like let's just say there was a username, I could come into here and I could manually add a watch called username, and it says, well, username does not exist in the current context. And so these watches are like very manual. Like, let me type in the name of my variable. In this case, I want like incidents. Okay, incidents is in scope. And again, this is just very manually, like, let me plug in my variable that I want to look for and see what the value is. If it's not in scope, it'll tell you. And so that's a breakpoint. Those are the important windows. Hit continue, it'll resume. If you want to get really like fancy about it, of course you could just come in here and remove it just by clicking the stop and go, you know, just come in, remove it. You can right click and disable, just temporarily disable a breakpoint. So instead of completely removing it, if you want to enable and disable, you've got that option. Again, this is just getting a little bit fancier, right? If you want to hit a conditional breakpoint, you can say, okay, I want to hit this breakpoint only when my loop I equals 500. Okay, I want you guys to imagine a for loop. This for loop is going to loop 1,000 times, and you don't want to step through the first 500 iterations of that loop. That's where you can insert a conditional breakpoint to say, hey, I want to skip over the first 500 iterations of this loop, and as soon as it hits 500, that's when I want this breakpoint to hit, right? And when you do this, now you can see it's got a different symbol, right? Looks like a red cross or something, right? Black cross. And so now visually you could tell that's a conditional breakpoint. And that's nice because who wants to step through 1,000 iterations of a loop, right? That's really where that becomes useful. So that's a fancy way to insert a conditional breakpoint. Now again, you could just click it and then right click and hit conditions. Okay, and that conditions will allow you to do that. Or if you just right click, you have insert conditional breakpoint. And that of course will bring up the conditions checkbox on this breakpoint where you can say where I equals I double equals 500, close. Okay, two ways of doing the same thing. And maybe you spend all this time to set up a conditional breakpoint and you don't want to disable that because you spent some time configuring conditions. Well, now it makes more sense to disable it versus just deleting it altogether. You have any?
I'm trying to think of like a time when that would be like useful to use, like a real world example of a conditional breakpoint. Like, what if you had like a data, you know, Facebook's database, and they have millions of users, and they know that the first 1,000 users are fine, but like it's this certain point, it starts crashing. Like,
Sure.
Is that an example of that?
That's a great example. Yeah.
Okay.
Yeah. And so you're looping over each user, and for each user you're doing something, and it crashes on the 1,000th user for whatever reason. It works on the first 999 users, but hits user 1,000. Why not hit a breakpoint at user 999?
But wouldn't the when you like skip through it, wouldn't it automatically just go until it breaks?
It does, but you're gonna have to hit F11 999 times. You see what I'm saying?
Yeah. No,
Instead of manually going through that loop 999 times, you just get the breakpoint to hit on 1,000.
Okay.
Yep. Very good. That's conditional breakpoints. Then the last thing I want to show you, and really the last thing that's in the chapter, because we talk about break mode, we've talked about the different stepping into and restarting and continuing. We've talked about the locals window, the watch windows. Again, watch windows just like very manual. I want to watch this variable, or I want to watch, in this case, movie.name. You know, I want to very much manually. Locals and autos and watches, we talked about that. Immediate is more of a command prompt window. So you're going to notice here, if you type a question mark movie.name, it'll respond like in a command prompt and say the value of that variable. It's literally like 10 ways of doing the same thing. Like you're just trying to step through your code line by line and see what the data is doing. I've used the immediate window like once in my life. I don't use it a lot because I can get the same information out of these other less command prompt oriented tools. The last thing here is a trace point, and you guys will relate to this because in JavaScript, we wanted to kind of see at different points in our code what the value of a variable was while it was running. And we didn't want to have to necessarily stop it from running. So what did we do? We did a console.log. Remember, we made these different debuggers, and these debuggers would be different colors. And we didn't have to stop the program from running. We just said, hey, in this method, this variable's value is blah, right? You guys will remember that. That's what a trace point is. A trace point is saying, hey, do a console.log, but instead of a console.log, it's just the output window. So let me demonstrate a trace point. And again, you guys will be very familiar with this because let's just say on the customer controller, I go to edit a customer. Okay, so here I look a customer up out of the database. I do customer.find ID. And again, just like the conditional breakpoints, I can right click and insert conditional breakpoint, or I can just insert trace point. Okay, so just off a right click, it's there to insert this trace point. Another way of doing the same thing, click it, and then right click actions. This is also a trace point. It's two ways of getting to the same point, okay? So if I just right click, insert trace point, and I want to say, okay, in the edit method of the customer controller, my customer name is, I'm going to put in some curlies, and I'll say customer dot first name, right? So in these curlies are where you put your variables, and I'm going to hit close. Okay, now you got to make sure to run it in the right mode, because if you run it without debugging, you're not going to get these debugging tools, right? So I'm going to run it with debugging. And of course I hit this breakpoint. I should have disabled it, but let's just hit continue. So here we go. So now let's go to customers. So here are my customers, and I'm going to hit Nina. I'm going to hit edit. Okay, now you notice I haven't, hit a break mode. I haven't stopped it from running. But if I minimize it and I go back to my output window, there's my output. In the edit method of the customer controller, my customer name is Anina, right? So this is the equivalent of a console.log. And it doesn't have to stop the program from running. It's just very useful to kind of log the data as the program is running so you can see that the data is what you expect it to be. So that is the last tool. Now, some of these tools, just being familiar with these tools will not make you good at troubleshooting. It's literally, you got to have stuff break. You got to have the experience of trying to fix it. That's how you're going to get decent at this, right? So those, but those are the tools. And all of those tools, if you don't remember, all of those tools were there in C#. And in some form or another, you kind of saw those in JavaScript as well. Yep. All right.